I'm going to show you an applet for confidence intervals. We notice we have two curves here. We have the original normal population distribution, which is the wider one. And then we have the more narrow one, which is the sampling distribution of sample means. In this case, our sample size was 5. But notice if I do change that, I can use a slider to make it larger. Okay, notice what happens as I make the sample size larger, the sampling distribution of sample means gets more narrow. Now it looks like the normal curve is getting flatter, but that's just because your applet is showing this curve getting more narrow, so it's trying to still fit both of them in. So that's what's happening there. Okay, so if I go back to sample of size 5, if I choose sample, what it does, it randomly chooses 5 data values. Okay, there's 2 here, and then 3, and then there's 2 right here. It's hard to tell, but there's 2 there. So that sample of size 5 resulted in a sample mean that was where this little dot is here in the middle of the bar. Okay, that value is the sample mean. What the bar represents, that's your confidence interval. So when you add or subtract your z star times sigma over square root of n, well, remember that z star is coming from how confident you want to be. Now I have 80 represented here. And then your sigma over square root of n, that's going to change depending what your sample size is. Now notice what happens if I make the confidence level larger. Okay, pay attention to what happens on the bar here. I'm going to make the confidence level larger. Okay, as I become more confident, so increase the confidence level, notice that the bar is becoming wider. And essentially what that's saying is, I went from, in this case, I went from 80 to 95% confident. So that means I need to fit more values in to become more confident. So that means the endpoints of your interval got higher on this end and lower on this end. Okay, so your confidence interval became wider. Okay, now if I keep that 95% confidence now, and if I do another sample, it's going to find another sample of size 5, find the sample mean, which is that dot in the center of the bar here, and then calculate the distance of z star times sigma over square root of n. Now in this case, z star with a 95% confidence level, we know that would be 1.96 because we've done that before. Okay, so if I do this several times, this is the idea of a confidence interval. As we keep on taking samples of size 5, okay, keep on taking them, notice how the sample mean is different, potentially different each time. But notice what's not changing here is the width of the bar, because z star 1.96 times sigma over square root of n is not changing. So the width of that entire bar is the same for each of these intervals. So as I keep on taking samples of size 5, notice that so far, every single one of these intervals has that center where mu is included in that interval. Okay, let me keep on doing, oops, sorry. Okay, if I take more samples, okay, well, let me do a whole bunch of them because it's not getting what I want. Okay, here, notice that way down here, after I took about 50 total samples, notice that it says 49 of them hit, which means that 49 of them included mu. That middle value there is included in the interval. Right here, this red one, that's the first time that the mean was not actually in that interval. Okay, and remember, the theory is, with a 95% confidence level, if you performed 100 of these confidence intervals, so you did this process 100 times, you would expect 95 of them to be intervals that contain the mean. So right now we're at a 98% hit rate, which is a little bit higher than 95. Okay, and if I just kept on doing this, sampling 25 at a time, so now it's actually calculating 25 at a time. Okay, there I'm up to 200 total, and I have 194 total that have hit, and 6 of them that have missed for a hit percentage of 97%. Okay, so here's 2 of them that did not hit it. Okay, now I could keep on doing this, but that's the theory of it. Now, if you have a picture of how wide that bar is, now let me increase the sample size. It's going to clear this out when I do this. But if I increase the sample size, okay, to quite a bit larger, I have a sample size of 50. Now when I sample, notice how much more narrow that bar became. That one just happened to be when it took the sample size 50. So it has 50 dots that it chose, or 50 data values from the normal population up here. And that gave a sample mean that was larger than mu, and the interval doesn't contain mu. So in this case, I took one sample and I already got one that didn't hit it. Okay, if I sample again, notice that one hit it, that one hit it. Okay, but notice that the width of that interval is much more narrow than it was when they had a sample size of 5. And it's really weird here. Like, you look at this and you see all those data values like really spread out. But when you take the average, remember what's happening here is you're averaging these together. So any data value that's way out here is averaging with one out here to the center. So if there's, say, 20 of the values out here, it's averaging with about 20 values out here, and they're going to average to the middle. So even though it looks like they're really spread out, when you average them together, they're going to tend to average toward the center. Okay, so it looks like if I keep on sampling there, if I keep on doing 25, well, here's 3, and this one didn't hit. So you got one up here that missed, one here that missed, and so on, one down here. Okay, now if I change my confidence level here, think about what will happen if I make the confidence level lower. Well, see what happens. Oh, it's not changing them. Maybe because I did sample 25. Let me reset that. Okay, if I sample a few. Can we go to a larger interval or confidence level? If I sample a few, and then if I become less confident, notice that it is making the interval more narrow. It's hard to see there, but if I get back to more confident, so we go up to like 99% confident, it made the bars wider because you need to fit more values in to become more confident. Okay, so that's just an Applet that kind of shows you what happens with the confidence intervals.